Hello, all my JavaScript friends. This is TheVirtuoid, aka Mike Smith, and this is our car racing game. Okay, here in video number 2, we're going to actually start looking at the graphics one piece at a time. So what I figured I would do is I took my race.js file. This is the JS file that generates was the main game controller and generates everything that you saw on the previous videos with the car racing and the sounds and all that kind of fun stuff. And I have taken that and commented out a ton of lines. And what we'll do is we'll uncomment those one at a time and explain exactly what's going on. So that's why what you're seeing here is a blank screen. This is about as blank as a screen as you could possibly get. So, there's nothing here. I mean, I'm trying to do something that, I can select time and finish, and that's about it. I can't do much of anything else. So let's take a look at how the graphics are built. Let's take first a look at the HTML file itself. And this is an extraordinarily easy HTML file. As you can tell, there's pretty much nothing here. Here are all the different starting lines. So I've got CSSs for red, yellow, and green. And off basically does a opacity for it, so it kind of looks like it's turned off instead of turned on. That's the reason you can see it. When you take a look at it, you can see the different changes as they go through the different countdowns. This is where the time is kept, where the finish line race results are set up, and then this is the actual world itself. That's it. I mean, there's nothing really to this HTML file. Of course, it's in the race file that we're going to actually go take a look at it. So the idea here is that when we create the race page is going to put up the HTML, and then it's going to put up this JavaScript file. And what it does, essentially, we get the two databases. We get access to the two different databases. We figure out what the canvas is. And then we create ourselves a new UI. And this UI is something I have created that basically allows me to be the interface between myself and Babylon.js. So my system will say, I need you to create me a box. I need you to create me a ribbon. I need you to create me a circle. I need you to do this, do that, and the other thing. And it goes to this UI system to be able to say, okay, I'm going to create it and give you a Babylon.js. If I ever wanted to go to 3JS or some other type of program, then I can just change UI and be done with it. This is kind of like a factory type method in which I don't really care who's running the graphics behind it. Just give me what I want. And that's what UI is all about here. Did I fully implement it? No, and we'll cover that in the very final video for the racing game. So basically, all I do here is I am saving what the library is, which right now is unused. But the important thing is what the canvas is, what all my meshes and materials are being used, and the instance itself. And I return the instance. This is a singular pattern. Basically, for instance, it's a singleton class. And once I create this class, it will put all its information inside instance. If I come back and create it again, it's just going to return the same instance. So this is a singleton class that once it's created, it can be created and used all over the place for any type of application, obviously within my application itself. And then what I do here is that I use static methods to be able to create the different pieces that I'm going to need for the application. And let's just go through those pieces real quick. Game data, we're done. The layout renderer, we already talked about that. This is where in the previous video, I get the particular venue from here. I go ahead and build the layout, and I get my starting position. All of this is stuff I need to know before I can actually create the screen itself. So there's some stuff coming, and then we just do a start. So let's take a look. We start, we initialize. It's within the initialization section that we're going to have all of the real fire occurs. The very first thing here is we're just getting funky stuff here, but within Babylon.js and within what I've decided to do is follow their particular patterns. First thing I want to do is create a UI engine. And this is going to be the engine that's going to control absolutely everything. And within the UI, basically, I'm just returning a new Babylon.js engine. That's it. We're passing it to canvas. So we create our engine. We're going to create our scene. And within Babylon.js, you have a scene that basic that's in which everything is put in. So if we go back to our screen here, this is my scene. As you can tell right now, there's absolutely nothing in it, but I have created a scene. The scene is tied into the engine itself. As we can see here, when we create the scene, we pass it the engine, and then we return the scene. And everything, notice everything is inside inside this instance. This again allows me to do the singleton pattern. So now I have defined a scene that uses the particular engine. And then I'm going to assign that scene to the layout renderer, eventually to the card renderer too. It's no big deal there. Then I'm going to create the camera. And this camera is the eyes, for lack of a better term. If I didn't have this camera right here, in fact, let's just do that real quick. Let's kill the camera. It'll probably end up erroring out on me. If we kill the camera, pretty much nothing is going to happen, because if we try to render something, we're not going to be able to see it. Of course, we haven't rendered anything, so that was kind of a worthless exercise. So let's just don't do that. So next is the camera, and the camera is the visual part. This is you and me and everything, and there's a bunch of different cameras that we can use within Babylon JS. What I have decided to use within the camera is something called the universal camera, and that will allow me to be able to have better control over where I want this camera to be positioned. And I need that particular, when I'm developing this system, I need to be able to, for lack of a better term, fly all over the place. This allows me, for lack of a better term, to fly, to use my mouse, use the arrow keys, and fly all over the place. And it basically allows me to, and that's really all it really does. I'm not going to go into details exactly what the camera does, but the universal camera allows me to fly around. I'm telling it to where I want to take a look at. That's what this section was right here. This is the actual position of the camera. This is what to take a look at. And in my particular case with the game, I have, or the racing game here, I have set there, and the camera is kind of offset a little bit from the starting position. That's what the SPX, SPOI, and SPC is all about. And I am looking a little further down the track so I could try to get, as a default view, the entire track within view. But you can replace this. You can place this camera anywhere you want. It doesn't really matter. Light is also something you need. You need to be able to light up everything within your Babylon JS, or how you'll be able to see anything. There's a bunch of different lights in Babylon JS, and I am using what's called a hemispheric light. Honestly, I don't think that's really the best light to use in the second part of this racing game, which we'll get to months and months and months and months down the road. Or maybe next month. I don't know yet. I haven't decided what I want to do with that yet. Maybe we'll experiment with different types of lighting that we could use. But this basically just allows me to do a general lighting that gives me the different lighting textures upon all the different meshes. Yeah, no big deal there. And then we do the load physics on there. This basically enables the physical engine, because Babylon JS by its default is just a 3D rendering system. You just put stuff on the screen and that's it. But by loading a physics engine, and it's called a Havoc plugin, this then again allows me to be able to do different physical stuff. This allows me to apply different physics to different pieces of or models within or meshes actually within the game. For example, all the different tracks will have a particular physics that tells them to say, stay in a place, don't do anything, but still interact with everybody else. While the wheels have different physical attributes or physics attributes, the different cars themselves, and they're told basically, I need you to turn the wheels and I need you to interact with gravity. So as you go down and you hit the ground, you'll stay on the ground, and the wheels will turn, so you'll actually move on the ground. And that's where this is the gravity vector that we pass to it. So we could actually do different gravity vectors. If we wanted to run this race on Mars, for example, we could change the gravity vector. Or if we wanted to run it on the moon, we could change it there too. So we can do a couple of very fun things with that. So that's where the load physics comes in, and I've commented on all of that. But once you've done that, absolutely still nothing will ever occur until you do what's called a render routine. So what happens here if we go back up in our race? When I do the constructor, the last thing I do is call start. Start initializes, and then, because this is a promise I'm returning, and then it does the render. And its own render routine the absolute minimum that you always need within a render routine is you need to declare a callback function for the run render loop for the engine, and this engine will basically run this code 60 times a second. FPS of 60, or as quick as it possibly can if it can't go quite to 60 seconds. And you can do things to get it to do different, FPSs if you wish. I'm not going to worry about that part. But the key here is that I want to go to the scene, and with the scene, I just want to render. So everything that has been loaded into the scene will get rendered, because I'll show you that here in just a second. Whenever we do create anything, no matter what it is, we always pop it onto the scene. So for example, on the create light here, we're throwing it into the scene. When we create the camera, let's see if we can get that on the screen here. When we create the camera, we're also throwing it into the scene. So everything, no matter what gets created, gets thrown into the scene. And you can have multiple scenes if you wish, but everything gets thrown into that scene. And so to render everything on that scene, it does the render function. And that will render one particular scene. Then the render loop will come through again and run it again and run it again and again and again and again and again and again. So that's how you get all of the motions to occur with any kind of objects that have been bound with the physics engine. This run render loop runs constantly all the time. And so the result of all of this is very simple. You get what is known as a blank screen because there's nothing there. So that's the basics of what you're going to want to have for your race. And again, you're going to want an engine, you're going to want a scene, you're going to want a camera, a light, a tilt to have physics, and then you want to have a little render loop. In our next video, we're going to start with the ground and work our way up from the ground.
Thanks for watching. Subscribe to this channel to view more videos. Click on the like button on this video and visit us at TheVirtuoid.com. Also, support us on Patreon, where you can get access to member-only videos. Links are down below. Again, thank you very much for watching, and keep on coding.